Hello, my name is Quinn Blackford, and today I'm going to be demonstrating some of the basics of the C++ programming language. And for this tutorial demonstration, we'll be using Visual Studio 2022. I will not be demonstrating how to set this up, but rather using the platform with the intention of showing new developers and people who are just getting started or maybe have never coded with C++ at all, and just getting them the beginning information about the language. If you do need assistance on how to get Visual Studio set up, I will leave a link in the description that will help you get it up and running. And in this tutorial, we will just be going over some core concepts and what it means to create the code. I'll be using a blend of layman's terms as well as the coding language definitions in order to try and bridge the gap between a novice's understanding and someone who has little to no experience with coding itself. It's important to understand these concepts first and foremost but learning the way that different coding practices are referenced will help with communicating with other software engineers and developers as you move forward. So it's good to establish the basics, but we'll try and relay these terms and functions in the easiest way possible. And so we're going to start off here by creating a new project inside of Visual Studio 2022. And we want it to continue without code. And it's going to bring you to this screen here. We're going to go to File, New Project. We're going to select an empty project. Go down here to Next. And we'll just call this Demonstration Project. And we can create that. Oh. I already had a file with that name, so we'll just call it Demonstration Project New. And so it's going to bring up this screen over here. It's going to bring up this Solution Explorer here that has now some more information. As you can see, we have a few files here, a few folders, but we're just going to be working with the header and the source files. Now if this Solution Explorer ever gets X'd out, you can pull it back up by going to View, Solution Explorer, and it'll pop back up in this window. Now things look a little bit different on your machine. You can move this around to various sections of your interface here. For now I'm just going to keep it here, but that's how you can move this around if this is not preferred. So to start out, to do anything with our project, we're going to need to create two different files. We're going to need our header file and our .cpp file. And so we'll just start out by creating a new file here. We'll right-click Header Files, go to Add, New Item. Make sure we select Header File here. And we're going to change the name for this to be Declarations. And now this is getting in the way because I was messing with it. But there we go. We can push it off to the side for now. Actually, I prefer that over here. And we'll resize that, and we're good to go. And we can delete this pragma once statement here. And we're also going to need a .cpp file. So we're going to go to our source folder, source files, add new item, do C++ file, and we'll just call this source. That'll work for our purposes here. And I'll start off by explaining what we have here. The header file itself is included usually to just keep our code organized, as well as increase the readability and maintainability of our program as a whole. While the header file can contain what we call the definition of our variables or functions, it's good to practice only declaring the functions in the header in order to save the definition portion of our variables and functions for the .cpp file, which is our source.cpp file. Respectfully, our CPP file page is going to contain the meat and potatoes of the program, so to say. So it'll contain the most of our logic that will actually define what our program will do. And so I'm already using terms like declaration and definition. So what does this really mean, right? To put it simply, when we declare a variable, it will tell our compiler what type the variable is and announce that it exists in our program. But it won't actually have anything to do in our program just yet. That's when we define our variable. That's when it's actually placed in our memory so that it can be stored and referenced later. And that's what also gives it its functionality, so to say, is with its definition. And we'll get more into that here momentarily, but I want to start out by going back to our .cpp file. And we're going to do a couple of include statements here. So we're going to want to do pound include less than, and it's going to create this less than greater than right here. And we're going to type iostream. And now what does this mean? So this include statement itself is going to include multiple files. And it will cause the program to compile a lot quicker as a whole, as opposed to if we were to type out all the files included in this iostream ourselves. And this will help us stay organized with our code. That will keep it fragmented into smaller chunks, things that are more understandable and readable in the long term. It also helps with refining code and debugging code. And this iostream itself, because we're including iostream, right? So what is iostream? iostream is considered a generic but very valuable library of code that will make the creation of this project and many other projects just a lot simpler. And for the purposes of this demonstration, it will be worthwhile to understand that the inclusion of this code will give us access to other functions within our program. Namely, for this demonstration, the standard input and output system are such functions that we will be working with, and that's what we're going to need this iostream here for this demonstration. And we're going to want to include one other thing. Just for ease of use here, we're going to include, do the less than greater than, and type string on the inside. Now what this string is doing is it allows us to work with a string of characters in succession. In short, it will be a means for us to place many letters and words together and store them into one variable without having to concatenate or combine various characters manually. And for the sake of this demonstration and getting started and learning the language, it's just going to save us a lot of time and effort. And so these includes just basically include a plethora of code into one statement, and it's pre-compiled when we run our program. And the libraries will just help us overall, just to get going. And there's one other type of inclusion sort of statement that's a little bit different. It's not pre-compiled, but it's what we call a using directive. So we're going to want to come down here a little bit, and we're going to type using namespace std semicolon. And that std is going to stand for standard. And so what does this all mean, right? The using directive directs the compiler to bring in the symbol names from another scope to our current scope, which is what is going to be the standard namespace, right? It's going to prevent us from having to type the clause std : before a lot of our commands are called in. And I'll explain why this is important for this program in particular, as well as how it can be tricky to use with larger programs. So for the purposes of this program, considering it's very short, it's just going to save us time typing std : before a bunch of our directives or a bunch of our commands. But it can be tricky because bringing in this entire namespace of the std standard, it comes included with a bunch of other function names and variable names that we might want to use ourselves, right? For example, instead of naming a function that would restore a character's health, you might name it just add instead of something like add life points, but the namespace std might include a function called add already, and so it gets confused and it's not sure if it wants to use that name or the function that you've just created, and all of a sudden you have a conflict of interests there, right? Now, because of this, just as a general practice, it's important to add or create a name for your functions and variables that are going to be very unique. Like I was just saying before, instead of just calling something add, you want to call it add life points. This is both to prevent a sort of overlap with the naming systems, but also to demonstrate just better readability with your code. It's pretty clear cut to understand what add life points does as opposed to just add, right? So the more clarity, the better when it comes to programming. And so we're going to move forward a little bit, and we're going to talk about these variables and functions I've been talking about, right? What does that mean? What am I talking about? Well, a function is basically a block of code that can be called throughout your program. And every program, or I won't say every, but when it comes to our demonstration here today, we're going to want a main function, which is going to be how we call our code and get it executed as we go through our program. And so in order to declare that, we're going to want to say int main, parentheses, curly braces, and then we're going to want to open these curly braces. And everything within these curly braces is the meat and potatoes. It's the main part of the function that is going to decide how our program runs. And we can also declare other functions to call within this function, and we will be doing that through this demonstration. And I think it'll become a lot more clear as we move forward how these are all going to work in tandem. And let's talk about variables for a minute here. So variable is essentially a container for information that we're going to want to use in the future throughout our code. And these variables will get stored in our memory space and allocated when we define them, and they will be accessible throughout the entirety of our program. Now, why is it important for us to do this? It's going to save us the hassle of having to retype the same information over and over again when we can simply reference the variable name and then have the value that's been stored in memory get referenced in its stead, essentially. So instead of typing, hello, my name is yada, 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 you can just type that once, store it into a variable, and then reference the variable, maybe it's labeled X, which is a lot shorter than typing out sentence after sentence, time and time again. Every variable is going to have a different type that is tied to it. For example, a variable may be declared as an integer type variable, which means that when we allocate that space in memory for the integer value, the integer variable, only integer values will be able to be stored in that variable. If we try to put a float or a string or character or bool type, it just won't store it because we've told the program to only allow integer types. And I think the best way to really understand all of these concepts that I'm talking about is really to just get in and start creating some of this stuff, right? And for now, we're just going to start out by declaring a variable. And as stated before, we're going to want to declare our variables inside of our header file. And so how we're going to do that is we're just going to say we want an integer type variable. We're going to name it x just to keep it simple. And we're going to put a semicolon. And for now, that's it. That's all our declaration is. What this does is it says we have an integer type variable, its name is x, and it exists. Now if we want to define what this variable is, we want to go back to our CPP file, and we'll say int x equals 0. Now what we've done here is just defined it by setting the place in memory of our variable as 0. So now there exists a spot in memory where this variable is. And now the reason for this semicolon at the end, you might have seen this done in front of, or at the end of this statement here, here, as well as here. And what these semicolons mean is it's essentially a period, right? It's an indicator that we're finished with this current line of code that we've been working on, and it just means to serve as a period to a sentence. It's important to add these semicolons at the end of every variable assignment, declaration, or usage throughout your code. And it's a very common mistake with first coding to forget these, and you may be left scratching your head as to why your code's not working. So just a friendly reminder to watch your semicolons there. I will say, before we get going too far, it's also important and good practice and essentially vital when you start working on bigger projects and projects that include multiple people to include comments on your code. And so comments will be a means to leave little notes throughout your program and your code that will remind you as to what your code actually does. And how you do that here is just by adding a double front slash, and you can see this green color indicates that we're commenting, and then you can put whatever you want. Like if you want to remind yourself this is a variable we have defined in our code, and it is being stored in memory. And now this whole line of code here will be ignored by our program. It is just there for us and other developers to look and be reminded of what things do within our program. Now, obviously, this comment is kind of redundant, but we are still learning here. So, if things seem overly simplistic or basic of understanding, it will make more sense, and you'll be glad it's there in the future when we come back to reference it later. So yeah, it's just great practice to get into commenting. It's going to help you out. It's going to help others out when you're going forward. And for that, I think we're going to cut this video short, and then we'll pick up in the next one, and we'll get started with some more concepts on coding in the C++ language.